Hello, my name is Robert. I'm one of the TFs of the class, and I'm going to go over some of these Turing problems that Brian posted. These are some of the sample problems found on the website. And this is one of the first ones right here. Now, these can be a little intimidating at first because you look at this thing and you have to figure out what this Turing machine is trying to do. And it can be just like a little overwhelming. Some of you might be able to just look at this list of instructions and figure it out. But the majority of us are going to need to chart it out and go through iteration by iteration with some sample input. So the first thing we're going to do is diagram it. And there's a couple ways to do this. First, we're going to basically list out all the states. So we're going to have, in this example, we're going to have 4 states. We're going to have the A state, the B state, the C state, and then this halt state. So we're going to start with this A, B, C, and the halt. Now, it doesn't really matter whether you put a C up here or a B up here or really anything. Just to be more intuitive, it's best to keep the A on the left, and then these other states kind of branching out. If you do make a mistake, or not a mistake, but if you put these in a non-optimal order, the worst that'll happen is you'll have arrows that may be crisscrossing each other. Now this, because it's so simple, there's really no wrong way to do this. And no matter how you format it, it will work. It just some ways may be more confusing than others. And you can change it as you go if you need to. This will be more seen in the next example. So basically we have these states and we need to take the instructions here and diagram it onto here. There's a couple ways to do it. One way is to draw all the arrows first and then put the instructions for what those arrows mean after. And I will demonstrate that in the next example. The other way, which I'm going to do here, is to do everything at once. For each label, also put in the instructions. And there's pluses and minuses to each of these techniques, and you just got to figure out which one works best for you. But for no matter what, we're going to start at the top of this list and move our way down so that all of these instructions are copied onto our diagram. So we're going to start with this top row. And here you can see that A is going to go to A, which means that we're going to basically loop around. And then we're going to copy these instructions right here. The first symbol is the current state. So basically, if the current state is this, that's going to tell us to follow these instructions. The next symbol in the middle says what to do with the symbol that we're currently on. So in this case, it says if we're at a space, then continue to leave that space, so there's not going to be a change. And then the next area is saying where we're going to move to on the tape. So we're going to either move left or right. In this case, there's a R, so we're going to move right. Moving down for the next arrow, we see that A goes to B, so we got this arrow right here. And it says that the current symbol is a 0, next symbol is, or the new symbol is a 0, and the new move is a left, so we got 0, 0, L. And we're going to continue this throughout. So for this next one, from A going to C, then from B going to halt, and C going to halt as well. So it's super important to make sure that you've transcribed these correctly. So it wouldn't be a bad idea to kind of go back and double check, because if you made a mistake and put the wrong number on any of these, your machine just won't get the same input. These two things won't be equivalent. If you did copy everything correctly, then basically all these instructions right here should be the exact same as what's here. This is just a more graphical translation of this list of instructions. So now we also want to keep a good idea, take a look at these assumptions. These are very, very important, particularly when developing or devising what test input we're going to use to figure out what this machine does. So it says the tape has zeros, ones, and spaces. So that means there's nothing like a 2 or a 3 or a star or anything else on there. It's just 0, 1s, and spaces. It says the digits come in a single cluster. So this means that you're never going to find a bunch of zeros with a space and then more zeros. Basically, all those zeros and ones are all connected together with no spaces in between. You want to also remember that this tape is infinitely long. So if there is a cluster, there's basically an infinite number of spaces to the left or the right. Obviously, we're just going to represent a couple of those spaces, but you can keep in the back of your mind that those spaces are continuous on either side. And then very important, it says that the scanner starts to the left of the cluster. So this means when we start our sample input, we're going to start at the left. So now what we're going to do is devise some sample inputs, and you can really use anything, but you want to do something that's relatively simple. So this is probably the simplest case right here, where we have 2 spaces, a 0, and 2 other spaces. And we're going to run through step by step to see what the machine is going to do with this input. I have some other sample inputs that we're going to try, and again, these are all very, very simple. And hopefully after we see what happens with all these inputs, we basically look at the output, we can then make an inference on what this machine is doing. So what we have here is I basically just copied the input to the Turing machine, and this allowed me to work on this area while leaving our original input alone, so I'll be able to compare the two at the end. So we're going to start by looking at the first digit right here, because it says we're going to start at the left, and we're going to be starting at this first area, which is a space. Now, when we start these, our initial state is always going to be A. So we're going to look at A, and we're going to see where is the current symbol a space. And we see it's this one right here. And what it tells us to do is to leave that as space and move to the right and stay in state A. So there's a couple things you need to keep track of. You need to keep track of what's going to be changing, where you're going to go on the tape, and what state you're going to be in. There's a couple different ways you can keep track of all this. You could write it down. What I'm going to do is I'm going to keep highlighted where I'm at, and you can represent this on a piece of paper by basically just having your pencil on there. As far as what to change the symbol to, we'll just do that a step at a time. And then I'll just kind of keep in my mind what state we're going to be in. But if you want, you can have another section of your paper where you record what state you're in, if that makes it easier. So again, we are right here. Says to basically leave this alone and move to the right. So now we're at this part of the tape, and we're still in state A. So we're going to, again, we're at a space, keep it a space, and move it to the right. So now we're at a new digit, and we're still in A. So this is a 0. So from A, we're going to go up here to B because our current symbol is 0. And we're going to ignore this arrow down here. So what this says is it's a 0. If it's a 0, then keep it a 0 and move to 1 to the left and go into state B. So we're not going to do anything here. We're going to move to the left, and then I just keep in mind that from here we are in state B. So from state B, we're at a space. So it says that if there's a space, replace that with a 0. And then it says to move to the right. And now at this point, we're in the halt state. So that means we're done. So this is basically all that's been done with this machine, or with this input in this Turing machine. So now we can test the further inputs. So again, I have exactly copied the input, so we can work on this, but leave our original input alone so we can compare them afterwards. And we're going to start on the very left-hand side. I'm going to go through this a little bit more quickly because we have a bunch of input to go through, but I'll just narrate what we're doing for each step of the way. So here we have a space on the very left. We go to our look and see what we do in state A. So we keep it a space and move it to the right and stay in state A. Again, another space, so we're going to keep it a space, move to the right, and stay in state A. So we're still in state A. It shows that it's a 1. So this time we look at our diagram. It says that if it's a 1, we're going to go to C, and we're going to keep that as a 1, and then move to the left. So we don't change anything to that and simply move to the left. And now we're in state C. Now from state C, we can see that if there is a space, which there is, we turn that space into a 1 and move to the right and halt. We turn that into 1, move to the right and halt, and we are done with this one. Moving on to this next one, we start with the space at the very left. We check and the space stays a space. We move to the right, staying in state A. From state A, we see that this is a 1. We keep it a 1 and move to the left, and now we're in state C. From state C, we see a space. We turn that into a 1 and move to the right, and now we're in a halt position. This next input, same pattern. Start as a space, keep it as a space, move to the right, stay in state A. From A, we see that this is a 1. It says we keep it as a 1, move to the left and go to state C. And from state C, we see a space. We turn that space into a 1, move to the right, and we halt. And we can probably get a good sense of what's going on by this machine by now, but I have one more just to double check. What's maybe a good idea is to kind of form a hypothesis of some kind after 1 or 2 or even 3 iterations. And then, once you're pretty confident, you can put another input in there to test. So this is our last sample input right here. So we're going to start at the left. It is a space. We're going to keep it a space, move to the right, and stay in state A. From there, from state A, we see that it's 0. We keep it as a 0, move to the left, and go into state B. From there, we're at state B. We see that we're in a space. We're going to turn that into a 0 and move to the right, and now we're in a halt state. So we can try this other sample input, and we would get this answer output once we run it through the machine. And from here, we can pretty much surmise what's going on. So what it looks like this is doing is it's reading the leftmost digit and copying it 1 space to the left. So here you can see it comes through from the left till it gets to the 0, and then it copies that 0. Comes through from the left till it hits this 1, and copies that 1 to the left. And it repeats that throughout these other examples. Here it comes across, hits a 0, copies that 0, and so on. So you may see this and think, well, this is kind of a pretty silly Turing machine. And I mean, it may be, there's really no apparent practical use of it. But as we'll see in further examples, these Turing machines can do some pretty cool things with some very basic input. So this is kind of just a good warm-up exercise, but as we get further along, we'll see much more complicated and useful applications of the Turing machines. All right, so we made it through that first example. Now let's make it to the second one. And this one is a little bit more complicated. I mean, it just looks more complicated. There's a lot more states. We have A, B, C, D, E, and halt. Much more instructions. One thing that's a little more simple is that it appears like we're only moving to the right each time. So there's not going to be any, moving to the right, then left, right, then left. And we can also look, most of these states pretty much have us not doing much changes. Really, it's only in these D and E states that we're going to be changing anything on the tape. The rest of it, we're just going to be basically going through. So it's kind of a nice idea, before diagramming everything, to just taking a look at the list and just seeing if there's any patterns that you notice. It may make it a little bit simpler when we're going through this and trying to determine what this Turing machine is actually doing. So now we're going to start with the diagram. So again, we're going to start with A, keep that on the left, and then we're going to do a B and a C, branching these out a little bit. Now I'm going to put this D down here for reasons that'll become apparent in a little bit, but it's not a big deal if you put it, just to the right of the B. Then I have this E here and this halt. Now, in the previous example, when I drew the arrows and instructions at the same time. This time, I'm going to do it a little bit different. I'm going to go through and put all the arrows in first, and then put the instructions in later. And we'll see why that might be a good idea. So looking at the first example, shows that we have an A state, we're going to an A, so I'm just going to put this little arrow back to itself. Next one is an A to a C. Then we have a B to an E. And then B to C. And then C to D. And it might be worth noting that, had we done it the other way with this D on top and E on the bottom, we would have ended up with these arrows crossing each other. Now, this isn't bad inherently because everything still works. It's just a little bit more confusing. So if you are at this point, you're drawing these arrows, you can kind of erase these and switch your E and D and continue the arrows forward. And that's partially why I like the idea of just doing these arrows first, just because there's a little bit less that you have to redo and erase if you do want to restructure your diagram. But you're perfectly capable of or able to keep it like this. You just want to not get confused by this crossing. But we're going to continue with the diagram that I do have. And so this next C is going from C to B. So we got that right there. And then this D going from D to halt. And finally our E to halt. So this is the structure of our diagram. Now I'm going to go through and go back and put all these symbols or these labels on them. So starting with A to A, got that, going from A to C, going from B to E, going from B to C, going from C to D, going from C to B, going from D to halt, and going. So here I have some sample inputs that we're going to put in our Turing machine. And it's important to note that I did look at these assumptions and creating them. First, this assumption right here says that there are only ones in there, so there are no zeros in. And we could see this would be a problem looking at our instructions, that there's nothing that tells us what to do if we did find a zero on the tape. It pretty much assumes that we're going to come across a space or a one. So if you didn't follow this instruction or this assumption and did some test input with zeros in there, you get to places where you wouldn't know where to go further. So very, very important, again, to look at these assumptions. Same as before, the characters come in a single cluster, so there's no spaces in between. And the scanner starts to the left of the cluster like before, so we're going to start over here. So just like before, I have my original input, and then this is what I'm going to go through to see what happens through this Turing machine. And I'm going to go step by step for this first one, and then we'll go a little bit faster for the next inputs. So we're going to start on the left, like the assumption says, and we're going to begin in A. And we have a space. So this says right here, if there's a space, keep it as a space, move to the right, and stay in state A. So we moved to the right, and I'm still in state A. So we're going to look, same thing, it's a space, keep it a space, move to the right, and stay in state A. So now we're in state A still, and we have this 1. So we can see from state A, if there is a 1, keep it as a 1, and move to the right and go into state C. So we are now in state C, and we have a space. So from state C, if there's a space, keep it as a space, move to the right, and go into state D. We are now in state D, and it says that if there was a space, turn it into a 1 and move 1 to the right, which we have just done. We changed that to a 1. Now, you may note that I didn't leave enough space for anything to the right, but there's an infinite number of spaces, so we can just kind of add that in. So here we are at our final state, because at this point we are now halted. So we can see that basically we went from this input and all it did is it added, or it skipped a space and put a 1. So from here, I can't really decide what this machine is doing, so we'll need to test these other inputs to see what's going on. So I'll go a little faster going through these. And I move things over again so we have some room. So starting with copying over that initial state of our tape, we're going to start on the left. In state A, we see that when we're in state A and there's a space, we keep it as a space and move to the right. Again, still in state A, we see there's a space, keep it as a space and move to the right. So from here, we're in state A, it's a 1. Our instruction says to keep it as a 1 and move to the right. And now we're in state C. So from state C, it says that if there's a 1, keep it as a 1, go to the right, but go to state B. So now we are in state B. We see a space. It says if there's a space, keep it as a space, go to the right, and go to state E. So now we are in state E. It says if there's state E, if you see a space, turn it into a 0 and move 1 to the right. So we turn it into a 0. Again, there are an infinite number of spaces to the right. I just didn't record them, so we can certainly add it later. So there we are at the right, and we're at the halt position. So still kind of, this time it went to the right, skipped a space and put a 0 in. Might be getting some intuitions of what's going on here, but I think it'll be a little more clear once we do this last one. So we're going to, again, copy our original input down and work our way through it. So we start at the space on the left, keep it as a space, move to the right, stay in state A. From state A, this is a 1, we keep it as a 1, move to the right, and go to state C. From here, we are in state C, it is a 1, it says keep it as a 1, and go to the right, and go to state B. So from here, we are in state B, it says it is 1, keep it as a 1, move to the right, and go to state C. So we are now once again in state C. So this says from state C, if it's a space, keep it a space, go to the right, and move to state D. So we move to the right. Here it is a space. It says change that space to a 1, move to the right, and go to the halt. So we move that to a 1, and we go to the halt state. So at this point, I think we might have a pretty good idea of what's going on here. It appears like if there's an odd number, as we see in the case of these 3 1s and this 1 1, it gives a 1. If there's an even number, such as these 2 1s, it gives a 0. So we can have this hypothesis that what this machine does is it determines if there's an odd or even number of 1s. And a really good way to double check that is to run another input. And I'm not going to go through this step by step, but if you did go through it, it would in fact show that 4 1s does give you a 0. So this answer is sufficient for, on an exam. But if you wanted to give a little more detail, you could be a little bit more specific, such as saying that, this machine takes, if there is an odd number of 1s, it adds a space and puts a 1. And if there's an even number of 1s, it adds a space and puts a 0. And you can also even, sometimes you might have a pattern that is a little difficult to describe. So you can do your best to describe it. But then you could also kind of give a sample input and output like the one right here. So you could say what it does, and you could say, for instance, if you get this input, you'll get this output. And that ensures that we know that you have a good idea of what's going on with this Turing machine. All right, so now we're on the last of the examples, of the 3 examples. And this one is definitely more complicated. Even though there are only 4 states, A, B, C, and halt, you'll notice that there's a lot more symbols being switched around, and there's a lot more variance in movement. We're going from left to right a lot, and right to left. So this is one that would be, even for people who find these intuitive, you're probably going to need to diagram it out. It's just not obvious from looking at this set of instructions what's happening. So we're going to do these diagrams just like before. And we're going to start with this A, B, C, and halt. And because this one's pretty simple, I'm just going to do the arrows and the instructions at the same time. So we're going to start at the top and just work our way down. So we have A going to A. It says if there's a space, keep it a space and move to the left. So space, space, L. Next one says go from A to C with going from, if there's a 0, turn it into 1, move to the right. Going from A to B, if there's a 1, turn it into a 0 and move to the left. Next, going from B to C, if there's a space, turn it into a 1, move it to the right. And then you'll notice that we have a second B to C. Now, I suppose you could just kind of have these instructions, both use the same arrow. I personally think that might be a little confusing. So it might be best just to have one arrow for every set of instructions. Even though these are both going in the same place, they have different conditions. So this one is if there's a space, do this one. This one is if there's a 0, do this one. Kind of interestingly, you do the same thing. So whether there's a space or a 0, you're both going to turn it into a 1, move to the right, and go to state C. But still, these there may be more complicated things in the future, so just keep everything separated. If there's a B, going from B to B, if there's a 1, turn it into a 0 and move to the left. And then from C, if there is a space, keep it a space, move to the right, and go to halt. And for C to C, if there's a 0, keep it a 0 and move to the right. So this chart doesn't look quite so bad just looking at it, but running through, we'll see that it's a little bit more difficult than some of the other ones. So we're going to start with some sample inputs. So again, keeping it very simple, just have these 3 basic inputs, and we'll run through and see what it looks like. Or sorry, there's 4 inputs and see what they look like. So again, we're going to basically copy that input, bring it down so we have one to work on and one to compare to. And critically, these assumptions, again, they are very important. It says that the scanner starts to the right of the cluster. So it's going to be somewhere over here. If you start it to the left, you're going to run into problems. Either, if you start it and there's just a space, as you see when you start at A, if there's a space, keep it a space, go to the left. You'll just go to the left for an infinite number of times. If you start with a number here, it'll do something different. But it's, it's not going to do what this machine is supposed to be doing because you didn't follow the assumptions. So again, tape has only 1 zeros and spaces, so that's true here. Characters are a single cluster, and we have single clusters. And the scanner starts to the right. So here we are at the right. So like we said, if there's a space, keep it a space, move to the left, and stay in A. So we're going to do that. So now we are still in state A. We're in a space, keep it a space, move to the left, and stay in state A. So now from A, it says if there is a 0, turn it into a 1, move to the right, and go to state C. So we turn it to a 1 and move to the right, and we are in state C. Now state C says if it is a space, keep it a space, move it to the right. And it says we are now halted, so we are done. So this is what the Turing machine did for this input, is turned that 0 into a 1, and that's it. So let's move on to the next input and see what we have going on. So again, we're going to start at the right. In state A, and it is a space. We're going to keep it a space, move to the left. It's a space. We're going to keep it as a space, stay in state A, and move to the left. So now from A, we have a 1. It says that we're going to go to state B, turn that 1 into a 0, and move to the left. So we turn it into a 0, and we move to the left. So now we're in state B, and we have this space. So it says right here, if there's a space, turn it to a 1 and move to the right and go to state C. So we turn that to a 1, and then we're going to move to the right. And we're now in state C. So now it says if we're in state C, we got a 0, keep it as a 0 and move to the right. And still in state C, if there's a space, keep it as a space and move to the right. And we are done with that. We basically turned this into this. Kind of interesting. Still not maybe quite sure what's going on. So let's just keep going in our examples. So we're going to take this input, start on the right. We got a space, keep in state A. We're just going to keep moving until we get to our first number, still in state A. So now we have a 0. So it says if we have a 0, turn it into a 1, go to state C. So now it is a 1, and then we're going to go to the right, and we're in state C. State C says if it is a space, keep it a space and move to the right. And we are done. So we'll do one more and see if we can figure out what is happening here. So we stay at the start on the right, and we're going to move over till we get to a number, staying in state A. So now we are still in state A. We have a 1. So it says we're going to go turn it into a 0, move to the left, and go to state B. So now we're in state B. We have a 1. It says to take that 1, turn it to a 0, move to the left, and continue in state B. So we turn it into a 0, move to the left, and from state B says that if there is a space, we're going to turn it into a 1, move to the right. So turn it to a 1, move to the right, and we are in state C. If there is a 0, keep it a 0, move to the right. Same thing, we have a 0, we're still in state C. 0, keep it a 0, move to the right, stay in state C. From C, it says we have a space. If there's a space, keep it as a space, move to the right, and go to halt. So we are now halted. So this is basically, we have this output generated from this input. And it may not be entirely obvious just looking at this, what is going on. Basically, to interpret this, you need to know a little bit about binary numbers. So a binary numbers in binary, basically, instead of this place being the ones place, well, this is the ones place, but instead of this being the tens, hundreds, thousands, 10,000s, in binary numbers, there can either be a 0 or a 1. So what that means is this is going to be the ones place, this is going to be the twos place, this is going to be the fours place, eights place, 16ths place. So basically, this is a 1. Whereas this says that there's one number in the twos place, so that is 2. There's 0 numbers in the ones place, so this number is 2. There's a 1 in the twos place, and then you add this 1 in the ones place, that gives you 3. And there's a 1 in the fours place, and 0s are everywhere else, so this is 4. I definitely recommend, if you're not familiar with binary numbers, to, there's some, Google a YouTube video that just gives a brief overview. You don't need to get too much into detail about them, but they might be important for this, for figuring out some of the patterns. And once we have this pattern here, we can see that this goes from a 0 to a 1, this goes from a 1 to a 2, this goes from a 2 to a 3, this goes from a 3 to a 4. And if we look at this pattern, this is a 4, and if we run this through the Turing machine, we get this 5. This is a 1 in the 4's place, a 0 in the 2's place, and a 1 in the 1's place. You add the 4 and the 1 together, you get 5. So it would appear that what this machine does is it increments the input by 1. So whatever number you put in here in binary, it just makes it 1 bigger. So on an exam, if you didn't know that about binary, it would have been really difficult to really explain what this machine is doing. You could probably find a good pattern to represent this binary increment function, but it's just so much simpler right here. So do keep that in mind. And there won't be really anything on the exam that hasn't been gone over in class. So we will go over binary at least enough to make this sensible in class. So there's nothing going to be unfair on the exam. So that is an overview of the 3 questions that we had, or the 3 sample problems that Brian gave us. If you enjoyed or found this step-by-step walkthrough useful, please let me know. If there's any changes or anything different I can do to make things a little more clear, please let me know as well. And thank you very much for watching.